Hi, my name is Ilhan Aslan. I present the ICMI paper titled PiHearts, Resonating Experiences of Self and Others Enabled by a Tangible Somaesthetic Design. I want to thank all co-authors for their contributions, and special thanks to Simon and Andreas, who carried out most of the practical work. Here we have an overview of the materials and the technical components of the design. The cover and shape of the displays are based on silicon. The method used to create the hard cover and shape is similar to how chocolate figures are created. The paper describes the making of PiHearts in more detail and so that it can be replicated. The hard display's main interaction modality is changing its shape. It beats like a real heart. Users can hold the display in their hands and feel the heartbeats based on senses of touch and proprioception. One can also see the shape changing when the heart display beats and hear the sound of the servo motors moving. PiHearts can be used to augment a shared everyday experience, to feel your own heartbeats or the other person's heartbeats in real time. The design has heavily benefited from our previous research exploring different materials to make these hard displays. It also conducted a workshop with experts in mindfulness-based stress reduction therapy, with whom together we have identified that the potential benefit of mobile and multimodal hard displays could be in enabling more opportunities for mindfulness practices and being inclusive in terms of providing access to such well-being and health practices to a broader range of users and a broader range of situations, such as patients in hospitals who are suffering from pain, or children in schools, or prisoners who may need assistive technology to focus on their inner workings and benefit from such practices. As a theoretical background, we use the works of Richard Schusterman on somaesthetics and Hartmut Rosas on social acceleration and resonance theory. So very simply put, somaesthetics provides a modern perspective on all kinds of bodily practices and experiences. One for the paper important aspect of somaesthetics is regarding the human body as living, as sentient, technically speaking, as somewhat autonomous, as a tool which is key in how we experience the surrounding world and how the world experiences us. Schusterman encourages a variety of body-centric practices to improve the body's utility and sensitivity, and thus enable our bodies, for example, to continue providing joyful and beautiful experiences. In contrast, Hartmut Rosa has been addressing issues which occur due to how our social lives have been accelerating. He has coined the term social acceleration to describe how today's society and people living in the society are suffering due to being expected to be busy all the time, to do things in parallel, to consume things quickly. And there seems no time to have stronger relationships anymore with the surrounding environment, and people may feel left behind. They may feel alienation as the opposite of resonance. In a way, in this paper, we combine these both theories to put emphasis on the role of the human body in resonance. So metaphorically speaking, we see the human body as an active antenna, which is capable to produce resonance or alienation. One such kind of signal are heartbeats, which can be both produced and sensed by the human body. The PiHearts design externalizes the user's heartbeats in an embodied and body-friendly manner. For the living and sentient body, it should be a familiar movement and sensation. Based on the theoretical background, we assumed that using the PiHearts would influence how one relates to the surrounding environment. We hoped that both display conditions, receiving your own heartbeats and receiving another person's heartbeats, would create feelings of resonance by simply heightening the sensitivity and expressivity of the bodies and enabling users to create stronger to their surrounding environment and people in their environment. We are not aware of any specific measurements tools to measure resonance. Therefore, we decided resonance as described by Hartmut Rosa. Therefore, we decided to use the next best thing, a game experience questionnaire, which includes a social presence module. This questionnaire measures constructs such as immersion and empathy, which we believe are important and describe how a person relates to their surrounding environment. To research the effect of using PiHearts, we conducted a field study for which we recruited 30 pairs of participants, with most pairs being in a romantic relationship. We asked participants to watch 3 movies, one after the other, varying the art display's modality and asking them to fill out the UX questionnaire after each movie. We controlled for any order biases using counterbalancing, and at the end of the sessions, we conducted semi-structured interviews asking questions such as what they like best, what they like least, and where they see potential and limitations in such a design. The data we collected with the questionnaires could be used to statistically compare the effect of the different display modalities on the selected and relevant user experiences. We found significant effects of display modality on the following items measured by the game experience questionnaire, sensory immersion, and the 3 items from the social presence module. Post-hoc pairwise comparison showed that when participants received their own heartbeats, they reported significantly higher levels of immersion compared to not using a heart display. And when participants received their partner's heartbeats, they reported significantly higher levels of empathy, negative feelings, and behavioral involvement compared to both of the other conditions. In the paper, we provide more results and discuss the results in detail. So coming to the end of this short presentation, we can say that the PiHearts design is an iterated and refined design which has benefited a lot from our past series of exploring different materials for tangible heart displays. We believe that the field study was appropriate to demonstrate the influence of using PiHearts on the user experiences. We also believe that the theories were very helpful in inspiring and understanding the interaction context, for example, being able to predict the outcomes and effects. There are some limitations, for example, in terms of our potentially simplified use of the theories and the designs focus on heartbeats only. Nevertheless, we see a lot of potential of combining somaesthetics and resonance theory for research in multimodal interaction. And we hope that this paper and work will inspire fellow researchers to study multimodal interaction designs for well-being, and more specifically to identify the interaction space available in multimodal designs to create feelings of resonance and harmony. Okay, thank you.